Hey guys, today I'm going to show you how to calculate the algebra side of the year 10 end of year revision. So let's just crack in and get started. So question 1, I'm just going to use a black pen for all of this, but there we go. Question 1, it says what value of x would make each statement true? So you've got to basically solve for x. So 1a, you got 48 minus 3x equals 36. Negative 3x equals 36 minus 48. So you've got to take it to the other side. And then simplify. Sorry. So 36 minus 48 equals negative 12. So x equals negative 12 over negative 3. B, you've got 4x plus 3, which equals 32. So expand the brackets. 4x plus 12, which equals 32. Take the 12 over to the other side. And you've got x equals 20 divided by 4. X equals 5. Question 2. A. So simplify the following expressions. So you've got a times a times a, which equals a cubed. 9r minus r, which equals 8r. 5d plus 3d minus d. 5 plus 3 is 8, minus 1 is 7d. 3p times negative 6q, which equals 8. 6 times 3 is negative, so we've got to carry the negative. Negative and positive is negative. 6 times 3 is 18, and then the signs pq, so negative 18 pq. E, you've got m to the power of 8 divided by m squared. So anytime you've got a situation like this, you've got to subtract the denominator from the numerator. So m 8 subtracted by 2, which is 6, m to the power of 6. F, x plus 3, x squared divided by x. So x plus 3x squared divided by x, you've got the x's cancelling out. You've got x plus 3x, which equals 4x. Question 3. Expand the following and simplify if necessary. So 5x plus 3 equals 5x plus 15. B, 2x minus 1 plus 3x minus 2. You've got 2x minus 2 plus 3x minus 6. 2x plus 3x minus 2 minus 6. 5x minus 8. C, x plus 3, x plus 6. So then you go, it becomes x squared plus 6x plus 3x plus 18. X squared plus 9x plus 18. Question 4. 4a. Factorize the following. So 4s minus 16 becomes 4s minus 4. D squared plus 5d minus 6 becomes d plus 6d minus 1. C, oh, you've got no C. Question 5. Question 5a. Solve the following equations and show all your workings. So solve for x. 8x minus 5 equals 43. 8x equals 43 plus 5. Um, 8x equals 43 plus 5, 48. Just have to double check. And x equals 48 divided by 8. 8 is 48. And B says 7x plus 4 equals 4x minus 32. So you got 7x, so take all the x's to the one side. Negative 32 minus 4, so 3x equals negative 36. X equals negative 36 divided by 3. X equals negative 12. Okay, question 6. Alicia, Liku, and Patty each have a bag of counters. Liku has 2 more counters than so it says Liku has 2 more counters than Alicia, so Liku equals Alicia plus 2, and Patu has 4 times as many counters as Liku, so Patu equals 4 times as many counters as Liku. Whoops. So 6a has asked, write an expression using A to show the number of counters in Liku's bag. So the number of counters in Liku, right? So Liku's bag would be, number of counters. So counter C equals A plus 2. B, write an expression using A to show the number of counters in Patty's bag. So number of counters in Patty's bag equals 4 times, remember it's 4 times the amount of Likus, so 4A plus 2. Question 7. Mason, Patrick, and Mustafa have 47 Pokemons. Pokemon trading cards between them. Patrick has 5 more cards than Mason, right? And Mustafa has twice as many cards as Patrick. So this could be represented by the equation. Solve the above equation to find out how many cards each of them have. So to solve the equation, x plus 5 plus 2x plus 5 equals 47. So you've got x plus, expand it out first, plus 2x plus 10, which equals 47. So you got 1, 2, and 4x. Sorry, let's just skip a line. 4x. And then you got the plus 15, plus 10 and the 5 of 15, which equals 47. 4x equals 47 minus 15. 4x equals 32, x equals 32 divided by 4, x equals 8. B, 7b, Koshi buys a tomato plant in the first week, so the first week, its height, it doubles its height, so 2x, right? So in the first week, the height, first week, height is doubled. In the second week, it grows 6 centimeters. So second week, height is 2x plus 6. In the third week, it grows 4 centimeters. Third week, height equals 2x plus 6 plus 4. Its height is now 32 centimeters. We'll write an equation to represent this situation. So 2x plus 6 plus 4 equals 32 centimeters. Solve your equation to find the height of the plant when it was bought. So to solve for x here, you'd go 2x plus 10 equals 32. 2x equals 32 minus 10. 2x equals 22. X equals 22 divided by 2. X equals 11. I hope I have this right. Yeah, 6 plus 4. Yeah. Equals 11. And now looking at this, a rectangle. Is this still part of B? Oh, whoops. It looks like it's still part of B. So a rectangle. So this is a rectangle. A rectangular field has a length, so this is its length here, and that's its width. So it says here, a rectangle has a length 10 meters longer than its width. So width plus 10, right? If its perimeter, which is the outside length, is 240 meters, and x represents its width. So what does x plus 10 represent? So basically it's the same thing. You got, instead of w, you've got x, and that's x plus 10. So x plus 10 represents the width. The length, represents the length of the rectangular field. Number 2, write an equation to represent the situation. So if it's talking about the parameter, so you've got, x, so x plus, so if we let me draw this all out. So you got x plus x plus x plus 10 plus x plus 10, and they said all of it equals 240 meters. Okay, so that's the equation. And number 3, solve your equation to find the length and width of the field. So So it would be x 1, 2, so 1, 2, 3, 4x plus 20 equals 240. 4x equals 240 minus 20, 4x equals 220, x equals 220 divided by 4, and x equals 55 meters. So you know that the width equals 55 meters and the length equals 55 plus 10, which equals 65 meters. Okay, moving on to question 8. Which one of the below expressions gives the largest value if n is between 1 and 2? Okay, so let's have a look at a couple of scenarios. So suppose n equals 2, right? Then you've got, for the first one you would get, so what's n minus 2? 2n, you've got an n squared, n divided by 2, and 2 divided by n. Okay, so here, let's take this out for a second. Right, so we're going to kind of like draw a table here. So assuming n equals 2, here it would be 0, here it would be 4, 4, 1, and 1. Assuming n equals 1, here it would be negative 1, here it would be 2, here it would be 1, half, and 2. Now, assuming n equals 1.5, you've got negative 0.5, so 2 times 1.5, you've got 3, 1.5 squared is 2.25, 1.5 divided by 2 is 0.75, and 2 divided by 1.5 is 1.33 recurring. 1.3 recurring. So let's have a look. When n equals 2, these two are the biggest. So, and then when n equals 1, the biggest number is these two. And then when n equals 1.5, the biggest one is this. So automatically, we can see that this one is expression gives the largest value if n is between 1 and 2. So 2n gives the largest value if n is between 1 and 2. Question 9. So 9a. So 9, Hunter was investigating different patterns for a splashboard to be installed in his new kitchen. He has grey tiles surrounded by white tiles. Complete the table. So you've got, grey tiles. Oh, whoops. And you've got white tiles. So grey 1, 2, 3, 4. You've given here 8 and 10. For 3, you've got 1, 2. 4, 3, got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Alright? And for 4, let's assume you've got 4. So you got 1, 2, 3, 4. So you've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 white tiles are needed if you've got 4 grey tiles. So that's that done. B. Write a rule linking the number of white tiles to the grey tiles. Well, this is a bit funny because let's have a look at the total, right? Of white and grey tiles. So you've got here 9, 12, 15, and 18. So automatically you can see that each one of these numbers is divisible by 3, right? So 3 times 3 is 9, 3 times 4 is 12, 3 times 5 is 15, 3 times 3 times 6 is 18. So this one kind of requires some thought and effort. So if we look at the first, let's look at when you have 2 grey tiles. So you've got so 3. What if you go 3 times the grey tiles? It requires a bit of trial and error. So 3 times the grey tiles is, so 3 times 2 is 6. 6 plus 6 minus g. So we can see that this formula so far works for when g equals 2. What about when g equals 3? So you've got 3 times 3 plus 6 minus 3, which equals 9 plus 6 minus 3. You've got 9 plus 6 is 15, minus 3 is 12, which is true. Yep. Let's have a look for, let's try it out for 4. So you've got 3 times 4 plus 6 minus 4, 12 plus 6 minus 4, which equals 12 plus 6 is 18, minus 4 is 14. So we know that this rule, using this method, this formula, works. To explain the number of white tiles needed. Okay, C. How many white tiles would be required if the number of grey tiles used is 20? So white tiles, so what? Okay, hold on. So grey tiles equals 20, so calculate white tiles, which is 3 times 20 plus 6 minus 20. And so 3 times 2 is 6, so 60 plus 6 minus 20, which equals 60 minus 20 is 40, 46. 46 white tiles will be needed. Okay. D. If Hunter needed 50 white tiles, how many grey tiles did he use? So this is basically solving for G, assuming we have, provided we have W, so 50 equals 3 3G plus 6 minus G, which equals, so you got to get, so it helps me if I have what I need to solve on the left hand side. So before I continue further, I'm just going to flip this around. So 3G plus 6 minus G equals 50. So 3G minus G is 2G equals 50 minus 6. 2g equals 44. G equals 44 divided by 2, and G equals 22. So you'd need 22 grey tiles for 44 white tiles. Okay, E. Draw a graph to represent the number of white tiles needed for grey tiles. Okay. So, 0, it goes up to 30. We might need to extend this. 5, 10, 20. Oh, whoops, it goes in increments of 5. 5, 10, 15, 20. Yep, we need to extend this higher. Okay, let's plop that down here. 5, 10, 15, 20. You got 25 here and 30 here. Okay, then you've got 1, 2, 3, 4, 5, 6, 7, 8. Okay, so it says draw a graph to represent the number of white tiles needed for grey. So if we go back to recreate something like this, this table right here, but instead of 1 to 4 we need 1 to 8. So let's copy this and just add on to it. Right, shrink this down. Can we shrink this down? There we go. Assuming we've got 5. So suppose we need to calculate 5, 6, 7, and 8. So again, what was the formula? So white tiles equals 3g plus 6 minus g, which if g is 5, 3 times 5 plus, 3 times 5 plus 6 minus 5, so 15 plus 6 minus 5, which equals 15 plus 1, which is 16. Okay. If it was 6, 3 times 6 plus 6 minus 6. So these cancel out and they become 18. 18. Then you've got 3 times 7 plus 6 minus 7, which equals 21 minus 1, which equals 20. And last but not least, if g equals 8, 3 times 8 plus 6 minus 8, so 24 minus 2, which equals 22. Okay. Now let's plot these. So these are your x and you've got your y. So this is your x and your y, and we know this because of the axes. So at 1 you've got 8, right? So 5, 6. Oh. So 2.5. 5, 6, 7, 8, 9. I think we might need to. Okay, no. Let's go ahead and plot it. So 1 is 8, which is around here. So 7.5 is in the middle. So yeah, I would say 8 is around here. Number 2 is 10. Right there. Number 3 is 12. Which I'd say is right there. Number 4 is 14. Number 5 is 16. Ooh, hold on. The axis is becoming difficult to draw. Maybe if we draw a bigger axis or a bigger graph, this will be easier. Bigger. So each line represents 1. Almost. There we go. Okay. So, that's gone off the page. Undo. Oops. Perhaps that wasn't a good idea. Well, what if we change the y-axis to go up in 2s? Maybe that would be a better idea. Okay. So so 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30. There we go. Okay, so let's back to plotting. Number 1 is 8. Number 2 is 10. Number 3 is 12. Number 4 is 14. Number 5 is 16. And number 6 is 18. Number 7 is 20. Number 8 is 22. So you can see there's this line. Or this gradient formed here. Okay. Question 10. 10a, it says, for the graph below, state the value of the y-intercept. So you can see the y-intercept is at -1. The gradient, so gradient is rise over run, right? So that's the gradient. So gradient here equals rise. It rises, so just the gradient is, so rise up 3, 1 across, right? So it's 3x. And then it says, okay, so it says number 3 is on the same axis, draw the graph. Okay. So this will be the middle. You've got 1, 2, 3, 4, 5, 6. -1, -2, -3, -5, -6. 1, 2, 6. -1. Oh, sorry. It's -3, -4, -5, -6. And you've got a line going either way, and I'm going either way here. So you got your y and your x. So here it starts out with -1, and it goes up here. Then it goes 2 and 5, right? And it goes -4 and -1. So the line here would go something like, whoops. Something like that, okay? And then it says draw y equals -2x plus 1. So the y-intercept, so if y is 0, if x is 0, the y-intercept would be -2 times 0 plus 1, which equals 1. So we know that the y-intercept is 0. The x-intercept is calculated when y equals 0. So y equals -2x plus 1. 0 equals -2x plus 1. -2x equals -1. X equals -1 divided by -2. X equals half. But no, sorry. Just don't worry about that. We can calculate a graph from one coordinate, or a line from one coordinate, which is 1, and a gradient, which here is -2. So down to 1, 2, and across, and it says plus 1, so to the right 1, right? Down to 1, 2, and to the right 1. Down to the right 1, and so on and so forth. So then this line would be drawn like so. Okay. Okay. Carrying on from the question, it says complete the table for the values of y equals 2x plus 3. Okay, so you've got x here and you've got y equals 2x plus 3. So x equals 3. When x equals 3, y equals 2 times 3 plus 3. And then you've got which equals 6 plus 3, which is 9. When x equals 2, y equals 2 times 2 plus 3. 4 plus 3, 7 equals 1. You've got y, which equals 2 times 1 plus 3, which equals 5. And when y equals 0, when x equals 0, y equals 3. Right, because 2 times 0 plus 3, 2 times 0 is 0, plus 3 equals 3. Negative 1, y equals 2 times negative 1 plus 3, which equals negative 2 plus 3, which is 1. And negative 2, y equals 2 times negative 2 plus 3, which equals negative 4 plus 3, which is negative 1. Okay, so let's draw this on the graph. So you got, starting here, you got, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You got negative 1, negative 2, negative 3, 5, negative 6, 1, 2, 3, 4, 5, 6, and negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. Okay. Okay, so complete the table for the values and draw the graph. So when x equals 3, y equals 9. So 3, y equals 9. When x equals 2, y equals 7. When x equals 1, y equals 5. When x equals 0, y equals 3. When x equals negative 1, y equals 1. X equals negative 2, y equals negative 1. So you can see there's this line, linear line, going right there. Okay, and that appears to be the end of the algebra section. Thanks for watching. I hope this has helped. If it has, please like and consider subscribing, please. I'll see you next time when I look at the measurement section of the worksheet. Thanks, bye.